Welcome, 6th graders, to your video lesson on representing situations with equations, tables, and graphs. Your goals today are that you can determine if an equation has an additive or multiplicative relationship, and that you can set up an equation, table, and graph given a real-world problem. If you have your notes template printed, great. Otherwise, please split screen this video with the notes template provided for you online. Activate that prior knowledge. You know a lot. Let's go. So first, we're going to look at the difference between an additive relationship and a multiplicative relationship. This is talking about the relationship between your variables, your y and your x, your ratios. IXL practice for this, if you are struggling at the end, is ZRU, if you can find it. So some examples. If you have a situation described as Owen was 2 years old when his sister was born, then that can be shown in a table by saying, okay, Greta, his sister, her age, X, and Owen's age, Y. Notice when Greta was born, Owen was 2. When Greta was 1, Owen was 3. When she was 2, he was 4. You'll notice the relationship there is that each time, each of these is going up. But what you'll notice is they're not always going up. Each of them, they look like they're going up by 1, but the relationship here, they're not equivalent ratios, like 2 over 0 isn't the same as 3 over 1, as you would expect later on when we do multiplicative. But you will notice that every time Greta's age changes, Owen is always 2 more than that, because that is an additive change. This can be shown in a graph it's going to start at 2. So when Greta was born, 0, Owen was 2. Then every time they age 1, well, each of them is aging a year, but the difference between their ages is always going to be 2. So this equation could be shown by Owen's age is Greta's age plus 2. That's an additive relationship. Notice that's going to go there not through the origin. Whereas what we're more used to seeing is maybe a multiplicative relationship, where the situation is, on average, it takes 2 minutes to complete each math problem. So you can see the relationship between x and y. For every 1 minute that passes, 2 problems are completed. So you can see here, each of these, we're going up by 2, up by 2, up by 2. As we go up by 1, 2 over 1 is the same as 4 over 2, and 6 over 3. That is going through the origin on a graph, because if no minutes pass, you don't solve any problems. And this, then, we can find any amount of math problems solved based on the minutes passing using a multiplicative relationship. The number of math problems solved is 2 times every minute that passes. Okay, so then looking for an additive relationship in tables, equations, and graphs. For a table, could look a little tricky, because if we look at this quickly, we see that we are changing, we can look at these as x and y, because that's what we're used to. We want to look at that relationship between y and x, that ratio. Here I have 10 over 5, 16 over 8. Those are all going to simplify to be that 2 over 1, meaning no matter what I plug x into, I'm multiplying it by 2 then to get to that output. So that was a multiplication. Whereas here, you can see I'm not necessarily multiplying the same thing, but I can see that I'm adding 3 each time. And so this is going to be my additive one. For a graph, again, additive relationship, you can compare that x and y. So here I have 30 compared to 15 is at the same relationship as 35 over 20, and it's not. And that's also not going to go through the origin. You can see that here. It's not maybe a perfect line, but if you can see, then we'd be going up by 5s each time. So we can see that that is going to be an adding 5 relationship there, whereas here we have 15 over 3, 20 over 4, and 25 over 5. Those are all going to have that each time we're going up 1, we're multiplying by 5. And then in an equation, it's much more simpler to see. Additive, we can see that we are adding our input to get to our output. So multiplicative, we're looking for, again, a relationship that we are multiplying our input to get our output. We are always multiplying by the same number now instead of adding, or sometimes it would be considered dividing. So here you can see we're going up 2 for every 1. You could look at it as adding 2, but you can also see here 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. So this is our multiplying by 2, whereas here we're simply adding 1, and those aren't all going to have that same relationship. So this is our multiplicative relationship there. In an equation, again, we can see that we are multiplying each input to get a new output. And then for that graph, again, I mentioned before, going through the origin is a telltale sign, whereas here it would go through there, here it's going to go here. So you can see my relationship is, I have 5 over 1, 10 over 2. Those are all going to be a 5 times my input to get my output, whereas here looks like we are adding again when we start at that 4, and then we're adding 1 from there. So that is multiplicative. So now we are going to tie a bunch together. You have practiced writing an equation, you've practiced making tables, and you've practiced making graphs. So now we're going to do it all together. So let's looking at this sentence. We're going to write an equation first. Lucy has 8 games on her iPad. She wants to buy more. The total number of games on her iPad depends on the number of new games she buys. So what we know is that she already has 8, so that's her starting spot. We know that she wants to buy more. We don't know how many more, so that would probably be a variable. Then it says the total number of games on her iPad. So we always know something is set equal to a total, right? And then that depends on the number of new games she buys. Okay, so let's think about this. We know that to write an equation, we need a y and an x, or in this case, we could name them other things if we wanted to too, but I'm gonna keep it y and x. So I know that we would have y, and that's gonna represent her total number of games. That's me defining my variable, so I know what that represents. I also know that she has x. This is the number of new games she buys. Bear with my writing. I said it, so hopefully you can read it. Rewind. So what would that look like then? Okay, so how many games she has is, well, the number of games she buys plus the 8 she already has. So this is an additive relationship between what she has and what she buys and what she will have. So let's make a table to figure this out. So I know that x, the number of games she has, or the number of games she's going to buy, and then how many games does she have, her total, will depend on that. And we know that what we're doing in the middle here is going to be our rule, the number of new ones she buys plus the 8 she already has. So what if she went to the store then? We'll fill in my table. What if she went to the store and just bought 2? So we would say, okay, 2 plus 8, she would then have 10 games. What if she went to the store and she bought 4? Okay, so 4 plus the 8 she already had, she now has 12 games. What if she went to the store and wanted 6 games? So 6 new games plus the 8 she had, now she has 14 games. What about 8? 8 new games plus the 8 she already had, 16 total games. And 10 new games plus the 8 she already had, 18 total games. So then what you're going to do is be able to graph that relationship, and you'll have to mark your axes. So we have x here. X is our number of new games. And our y-axis would then be the number of total games she owns. And you could maybe change that. You could write total games she has. And then you could title your graph, of course, too, which we should do. We know our origin is 0, 0. She buys 0 new games. We didn't put that in our table, but that might have been a good thing to put. If she buys 0 new games, she already has 8, though. So what you're going to want to do is label your axes, though, here and do them in intervals. So I might go 2, 4, 6, 8, 10. I counted by 2s and marked them by 2s. And I can continue on just to keep it going. And on the y-axis, I know that I kind of want to be able to show at least up to 10. I want to go up to that 18 output. And I know this only goes to 15. So maybe I decide that each of these is worth 2, and that's 2. And then so the next one, 4, 6, 8, 10, 12. And they're going by 2s. That might be something you want to consider if that would be helpful. in getting all the way to that 18. I guess that would be 18, sorry. So that might be something you want to consider on making your intervals when you make these. So going on, then I'm going to plot my points. I know that if she buys 0 new games, she still already starts with 8. She has 8. And then if she buys 2 new games, she'd have 10. And you have your ordered pairs here right from your table. So then I can just plot those right from the table. So it was 2 and 10, 4 and 12, excuse me, and 6 to 14, 8 to 16, and 10 was 18. And we can see that this trend would continue. We can put a line right through there to show our additive relationship. See if I can make this one a little smoother. Maybe you want to try on your own and come in and check every now and again. So Luther is downloading some games on his phone. Each game he buys costs $2. So each game is $2. The total cost depends, so that means that's our output, right? It depends on something else. That depends on the number of games he buys. We're looking at games again here. So that's the input. Okay, so the total cost. So now our variables, and again, you can do different letters if you'd like. So I could say C represents total cost. And then I can say G is the number of games he buys. So then the equation would be represented by the total cost is $2 per game. So right, he buys 1 game, it's $2. He buys 2, it's 4. That input output. So we can use that equation to help us make a table. We know that he's buying games, G, and that each game costs $2 each. It's a multiplicative relationship, and that'll give us our total cost, C. So for simplicity's sake, we'll go by intervals of 2 again. So say he wants to buy 2 games. That's going to be $2 for each game. So 2 times 2, he'll spend $4. If he's going to buy 4 games, that's $2 for each game. 2 times 4, he'll spend $8. 6 games, 2 times 6, he'll spend $12. 8 games, that's 2 times 8, he'll spend $16. And then 10 games, $2 for each game. 2 times 10 is $20. So again, what you've created now is ordered pairs. We have input of 2, we get output of 4. Input of 4, output of 8, and so on. And we can see that relationship of that multiple of 2 between y and x there. And of course, we're going to label our axis. So our G, in this case, is our x-axis. So we could say G. That represents number of games purchased or bought. And our y-axis means total cost or total amount spent. And this title of this would be representing Luther's video game purchases. So again, I'm going to go here. These are just by 2s. We have our 0. If he buys 0 games, he's going to spend $0. If Luther buys 2 games, he's going to spend $4. So I was going to go up. Do I want to go do these by 2s again like I did last time? I sure could. So then I can make this 4. And if he spends $4, he was going to make 8, so that's 6, 8. If he spends $6, it was going to be 12. If he spends 8, it was going to be 16. And then 10, that was going to be 20. And of course, I should have done this first, but I'm going ahead here. 8, 12, 16, 20. And we can see that line that's going to continue in a multiplicative relationship 2 times. Okay, last one. A little bit of a combo here. Vanessa plans to order pizza, but needs to research to determine costs. Looking at Pizza Parlor Menu, she sees that each medium pizza is $7, and there's a delivery charge of $3. So we want to represent this scenario for the input and output. So we know that she's looking at buying each medium pizza $7, and there's a delivery charge of $3. Well, they're going to deliver it just to deliver it, not per pizza. So it looks like we got to determine our cost. So our outcome would be our T is our total cost. And our cost, it looks like, depends on the pizza, the number of pizzas she buys. So the number of pizzas. Those are our defining of our variables. So it looks like to find the total cost, she would be doing, well, $7 for every one pizza she buys plus that $3 delivery fee. So let's make a table where P is our input, total cost is our output, and our rule is that we are multiplying each pizza as $7, and then we have a one-time $3 delivery charge. So if I buy one pizza, that's 7 times 1 plus 3, it's going to cost $10. If I buy two pizzas, or Vanessa, I'm Vanessa today, 7 times 2 is 14 plus 3, she'll pay $17. 3 pizzas, 3 times 7 is 21, plus 3, she'll spend a total of $24. 4 pizzas, it's $28, plus 3, she'll spend $31. And then 5 pizzas delivered, she'll do 7 times 5, $35 on pizza, plus a $3 delivery charge for $38. So again, we know we get our ordered pairs there from our input and our output. For our graph, I see I'm going all the way up to 38 and I only have 15 on my slot. So I know that I'm going to have to do some intervals here. We know 0. We know my x-axis, my input, is the number of pizzas purchased. My y-axis, my output, is my total cost. So I'm going to have, I'm going to kind of each half here go by 1. So 1, 2, 3, 4, and 5. On the side, I'm going to have it go by 3. So each one line is worth 3. So I can say 3, 6, 9, 12, 15, 18, 21, 24, 27. So you can kind of go like by that, and then that'd be 30, 33, 36, 39, and 42 up here. So just kind of knowing what your intervals are and staying consistent. You can't go by 3 once and then 2 the next. So let's plot our points. If they're by 0 pizzas, well, you're not actually going to have a delivery either. So this one's kind of interesting because you're not going to have them deliver you no pizzas. So that's kind of interesting on this one. So 1, though, if I buy 1 pizza, it's going to be $7. So it's going to, or sorry, 7 plus 1, so it's going to be 10 right above that 9. 2 pizzas, we had 17. So I'm just plotting points now based on my coordinates. 3 pizzas was 24. 4 pizzas was 31. 5 pizzas was 38. So I'm just trying to line up here. And then, of course, I can draw my line to show the cost of my pizzas. And you don't have to do that 0 one, really. It's going to be a little bit of a dip there. We could have put it at the 3. That would have been made more of a straight line, right? But I doubt you're going to have anyone deliver you nothing. So there you go. All right, friends, hopefully you worked hard on practicing there and making connections. Use your knowledge and these notes to do more practice. Today, your assignment is that you're going to go to iExcel and complete both. I think we were actually going to change this, ZRU. And you can't find that, then your alternate to that could be 6Z16. But then you will also do 6Z14. So they could be this one or this if you can't find it. So you're going to get each of those to 50 plus. You'll be needing these scores to create these skills that we just did to create your own situational equations, tables, and graphs coming up. Good luck.